Welcome! Today we are exploring the D block and the F block elements with a special focus on the transition metals, lanthanoids, and actinoids. First, the D block sits in the middle of the periodic table spanning groups 3 through 12. Let's visualize the first row of transition elements from scandium through zinc. Their general electron configuration follows n-1d superscript 1 through 10 followed by ns superscript 0 through 2, which is why they occupy all 10 d orbitals. Transition metals tend to occur as ores in the Earth's crust and are extracted by reduction methods. They share a set of typical characteristics like hardness, high density, and good electrical conduction due to the mobility of d electrons. Here are the general trends for the first row transition metals. Metallic character remains high. Ionization enthalpy gradually increases. Oxidation states are variable, with the middle elements showing the widest range. Ionic radii slowly decrease because electrons are added to the same subshell. The compounds display a wide variety of colors because of the d-d transitions. Catalytic properties appear since partially filled d orbitals allow adsorption of reactants. They are often paramagnetic because of unpaired electrons. They form strong interstitial compounds with small atoms like hydrogen. Finally, they alloy easily with other metals, boosting strength and toughness. Two important D block compounds are potassium dichromate and potassium permanganate. Potassium dichromate is orange and prepared by oxidizing potassium chromite. It is a strong oxidizing agent in acidic medium. Potassium permanganate is deep purple and prepared by alkaline fusion of manganese dioxide. It is also a powerful oxidizing agent and is widely used in titrations. Now let's move to the F block with the lanthanoids. Their general electronic configuration is the xenon core followed by 4 F electrons filling from 1 to 14, with 2 6s electrons. They almost always show a +3 oxidation state, and their chemical reactivity is similar because the 4 F orbitals are buried. Lanthanoid contraction refers to the steady decrease in ionic radius from lanthanum to lutetium, which affects the chemistry of later transition metals too. Actinoids follow lanthanoids in the periodic table. Their electron configuration begins with the radon core and fills the 5 F orbitals, often with more than one electron in 6d or 7s orbitals as well. They display a wider range of oxidation states from +3 to +6, and they are all radioactive with more complex chemistry. Compared to lanthanoids, they are less stable, and their radii change more sharply because the 5 F electrons are more exposed. That wraps up our guided tour of the D and F block elements. The transition metals bring diversity through the d orbitals, while the lanthanoids and actinoids fill the F orbitals with subtle effects on size, reactivity, and radioactivity. Keep exploring and stay curious.